So this is what we have from yesterday, page 25 in your notes. So this stoichiometry uses the balanced chemical equation to determine amounts of reactants in products. Now, a lot of you were not here yesterday. These notes that you're looking at on the screen behind me, they will be posted on Google Classroom today after we finish them. But you'll want to have these because you can use them on the test. The test apparently is Friday. Today's Tuesday, so we're going to practice this stuff today, tomorrow, the next day, and then the test will be on Friday. So all of these problems that we're going to work on start with mass of one thing in a chemical reaction and ask about the mass of another thing in the chemical reaction. These are often called mass problems. And they always will go grams to moles, moles to moles, moles to grams. And I'm not going to sing the rest of that song for the benefit of the people watching this video. So that's how this will always go. So yesterday we were about ready to do this example at the bottom of your notes. And I'm going to see. Okay, we're going to do this example that's at the bottom of your page 25. Now, the first step is to balance the chemical reaction. And we did that yesterday in class. The coefficients we put in were 1, 3, 2, 2. So if you haven't done that, please be sure you do that right now because that's the start of solving these problems. The second thing to do is to identify, and I mean, you get a point for doing this, right? So you're going to identify what it is you are starting with in the problem. So here you are starting with 36.1 grams of B2H6. That is the stuff we know at the beginning of the problem. And it's really important to note that, otherwise you don't know where to start. And it's also really important to note what are we asking for at the end of the problem. And we're asking for grams of HbO2. That's what we're asking for at the end of the problem. And you can put a question mark or you can put unknown. There's several ways of noting that. Now, we're going to start, and if you have the notes up here, we're just going to follow this. Oops. We're going to follow this starting with grams of known and converting to moles of known. In this example, it's chemical A. And then we'll use the mole ratio. That's this part right here, the mole ratio from the balanced chemical equation that has moles of B for moles of A. That's what makes the conversion from one thing in the reaction to another. So let's just go through this example. So I'm going to write down what we're starting with, 36.1 grams of B2H6. And we're going to make a conversion from grams to moles of that chemical, which means we want this unit to cancel out. So we're going to write this unit down here, grams of B2H6. And up here, we're going to put 1 mole of B2H6. So the number that goes here, we remember as the molar mass of this compound. So we just have to add 2 borons and 6 hydrogens together to get that molar mass. So 2 times the mass of boron. And then look up boron on the periodic table. You're going to want to be sure you can do that when we're practicing these. Boron has a mass of 10.81. So we just multiply that by 2 since there are 2 borons. And I should be using my calculator. You guys have some calculators. Check me and see if I get this wrong. Is that 21.62? Did I get that right? Thank you. Okay. We also need to add the mass of 6 hydrogen that are in the compound. Each hydrogen, we look that up on our periodic table. Each hydrogen is 1.01. 6 times that is 6.06. So I'm adding these together and I get 8, 6, that's 7, 2. So 27.68. Some people might even round that up. Excuse me.
Pardon the interruption. Today's start is the start of registration. Throughout the day, we will be calling down juniors, class of 2027, by last name to go to the library where their charge Chromebook and their graduation requirement sheets they received in advisory yesterday. Please make sure students are being dismissed by grade level, that's juniors today, when their first initials of their last name is called. Again, today we are calling down juniors to do registration in the library. Students must bring their charged Chromebook with them. At this time, we will take students with the last name A as in Apple through E as in Ernie. Those students can proceed to the library. A as in Apple through E like Ernie. Thank you.
Okay. Now, somebody was asking about ASVAB. I did a search on my email, and I don't have anything regarding ASVAB for this week, so I don't know. Can't tell you. If you think you need to go check, you could go check on that. Okay. The molar mass of B2H6 is about 27.68 grams per mole. So that's the number that goes here. So these units cancel out and we've gone grams to moles. That's the conversion we have done. So I'm just going back up here to step 4. We've gone grams to moles. Now we're going to use the mole ratio from the balanced chemical equation. The mole ratio from the balanced chemical equation. I'm going to put that in our notes in black so that it stands out a little from the purple. That's the next conversion factor we are putting in. Now, what do we put on the bottom and what do we put on the top? Well, on the top always goes the new thing we are looking for. That's the thing we have labeled here as the unknown. That always goes on the top, and that's HbO2. So on the top is moles of HbO2. And we will always use the coefficient from the balanced chemical equation. That's this number right here. I'm going to highlight it in just a moment to see where we got it from. So this number right here comes from this coefficient in the balanced chemical equation. And the number here comes from the coefficient in the balanced chemical equation for B2H6. How do we know that? Well, let's write that detail in. Because we want this unit to cancel, and we always put this unit on the bottom, the one we started with, moles of B2H6. And this is why it's important to label these, because it's so easy to get confused. We're going to cancel out these units that factor out because they're the same on the top and the bottom. So what's the number in front here in the green highlighted area? Well, that's the number from the balanced chemical equation. So that is the mole ratio. That's really the new step you've learned here. All the other steps we had been doing previously, and we've just added them all together. So here's the last step. I just want to go back up to we've gone grams to moles of the first chemical, and now we've moved to moles of the second chemical, and now we're going to go to grams of the second chemical. So this unit is grams of the second chemical, HbO2. And we want the grams per mole. And you remember that's called the molar mass. So we have to calculate somewhere the molar mass of HbO2. So that's 1 hydrogen, 1 boron, and 2 oxygen. So that's 1 times hydrogen is 1.01. Boron is 10 point, I'm looking it up again to make sure I don't get it wrong, 10.81. You will always have a periodic table when you're doing these. That's 2 oxygens, 2 times 16. 2 times 16 is 32. And so I'm seeing 43.81. Okay, we have the hard work done, but now you have to do the careful work of putting these numbers into your calculator. And remember, we're always multiplying by the thing on the top, dividing by the thing on the bottom. Multiplying by the thing on the top, dividing by the part on the bottom. Multiplying by the thing on top, dividing by the part on the bottom. So, I do not seem to have a calculator on my desk. How could that be? If you don't have a calculator on your desk, we'll get one to you in a few minutes. So I'm going to put this in order from left to right, following those orange mathematical operations. So I'm just going to do 36.1. I'm going to do times 1 divided by 27.68. I'm kind of checking my display to make sure I haven't made a mistake. Now I'm going to go to the mole ratio times 2 divided by 1. And then I'm going to go to the last step, times 43.81 divided by 1. And I get 114 and a little bit extra. I'm going to round it up to 114.3. 114.3. But I'm not done. I am not done. That's not the complete answer. That's a number, but it's not a measurement. You have to turn it into a measurement by looking at the units that should be here. I left off a unit B03. That cancels there. And so I'm left with the unit grams of HbO2. And that, ladies and gentlemen, is my final answer. Any questions? You have it in your notes. You can practice this now. So I'm going to see if I can stop my recording.